Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will explore a fundamental and key concept in mechatronics control technology, control principles of open-loop control system. Through in-depth analysis in this lesson, I hope you will gain a clearer and deeper understanding of this field. Our lesson will cover the following 4 main topics. Through this lesson, we hope you can accurately describe the working process of open-loop control systems, analyze their advantages and limitations in different application scenarios, and determine in which situations open-loop control is suitable. Before we dive deeper into control principles of open-loop control system, let's first understand the basic concept of a control system. Control systems are an essential part of engineering, regulating the behavior of the controlled object to achieve the desired goals or functions. Now, let's first look at the overview of the control principles of open-loop systems. The control principle of motor open-loop systems can be summarized as follows. The controller receives the input signal, generates a control command. The driver converts this control command into a signal that the motor can understand, and the motor operates based on this signal. Since the process does not involve a feedback loop, it is called open-loop control. Now, let's first look at the control principles of open-loop systems. First, we need to clarify that the control process of an open-loop system is a one-way, non-feedback flow. Specifically, its control principle can be summarized in the following steps. 1. Set the target value. Based on actual needs or application scenarios, we first need to set a target value or desired value. This value will be used as the reference for the controller's output. 2. Calculate the control signal. The controller calculates the corresponding control signal based on the set target value, using internal algorithms or logic. This control signal is directly passed to the controlled object. 3. Execute the control action. Once the controlled object receives the control signal, it performs the corresponding action or response. This action or response directly determines the actual state or output of the controlled object. 4. No feedback adjustment. In open-loop control systems, the actual state or output of the controlled object is not monitored or fed back to the controller in real time. Thus, the controller cannot adjust the control signal based on the actual response of the controlled object. Now, let's analyze an example of the control principle of open-loop systems. To better understand the control principle of open-loop systems, let's analyze a simple example. Imagine we have an automatic door system that uses open-loop control. When someone approaches the door, the sensor detects the person's presence and sends a signal to the controller. Once the controller receives the signal, it immediately sends a command to the motor to open the door. During this process, the controller does not monitor the door's status or position in real time, but instead directly controls it based on the sensor's signal. This is a typical application example of the control principle of open-loop systems. 4. Limitations of the control principle of open-loop systems. Although open-loop control systems demonstrate unique advantages in certain scenarios, they also have limitations. Due to the lack of a feedback mechanism, open-loop control systems cannot monitor the actual state or output of the controlled object in real time and adjust the control signal accordingly. This may lead to discrepancies between the actual state and the desired state of the controlled object and even cause potential safety issues. Through today's lesson, we have gained an in-depth understanding of the control principle of open-loop systems, including their working process, features, application examples, and limitations. Open-loop systems are mainly applied in situations where high precision is not required, such as household appliances, simple industrial equipment, and static control systems. These systems have the advantages of being simple in structure and low in cost, but have the disadvantage of being unable to correct system errors, leading to lower motor operating precision and stability. Therefore, when selecting a control system, we must weigh and choose based on the actual needs and application scenarios. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.